Solve for substitution, which should be your next page. Pardon me?
Oh, he's talking to me.
Oh, okay. Okay, now you will notice there is only 3 examples on this page. Indeed, that is the end of the lesson. Because it is one of those things in math where the only way to get good at it, because there are absolutely no tricks or pitfalls or anything like that, is to practice. It's just like factoring. Okay? If you practice a million factoring questions, you start to be able to factor without writing anything down. That's kind of how this works. All right? So you can all read that box there. You could actually probably, I bet, read that box and do these 3 questions completely by yourselves. I could sit here and twiddle my thumbs. Of course, I'm not going to do that because then I would feel bad about getting paid. But what I am going to do is allow you a second to read that box right now, and then I'm going to highlight a few things that kids often make errors on. All right? So you guys go ahead and read that first box there. Does any of that not make sense to anybody? Like, are any of those words bothersome to you or the way it's written? Everyone's cool with what all those words mean? Right? Everyone can see the theory? Okay, so all we got to do is practice it now, yeah? So let's do that. Now remember, what? Yes. Now remember, with a system of equations, you're working with both equations at any given time, right? Because you're going to find the single set of coordinates that satisfy both equations. However, you are also aware of a couple of other things when we do algebra. Mr. DeVries.
Sorry to interrupt.
No problem.
You got a grade 11 course right now?
No.
Of course not. I'm just daydreaming. Okay.
Okay.
But you have some 9s.
Yeah.
Yeah. Okay, your final exam
Oh, okay.
is going to be 8:30 on Thursday, June 23rd. Does that work for you?
Yeah. And we don't know about the provincial, or do we do?
10 provincial is on Monday, the 27th.
Okay. At 8:30.
12 o'clock.
12 o'clock. There you go, ladies and gentlemen. That's my sister's birthday, in case anyone cares.
That's my mom's birthday.
And it's my kitten's birthday. Because they had them on my feet. All right. What was I saying? Oh, right. You are working towards a solution to both equations. But at any given time, you are only working with one equation. Understand? And the second pitfall that seems to bother kids when they are dealing with systems is the fact that until grade 10, what happened when you had 2 variables? You guys didn't have the mathematical or algebraic skills to deal with 2 variables, did you? The only thing you've done is make tables of values where you choose an x, right? And then find out what y is. Agreed? You all know how to do that. That's essentially all we're doing here. But now you can use it to actually work with 2 different variables. Now remember, in math class, the variables are always x and y, right? Because it's the basic skill. Out in the real world of doing calculations and making models and things like that for actual use, the variables aren't going to be x and y, but the skills still apply. Okay? Everybody cool? All right. So looking at this first one, which of those two equations should we start with? When I read the box here, I should start with this first one, yes? That is step one. Why do I start with that first one? Joel, what was your reasoning?
Because it has a variable with the coefficient of 1.
Right. This guy has a variable with 1 coefficient. All right? Now, it might be x or it might be y. Don't get in the trap that sometimes happens of thinking to yourself, oh, I always have to find x. Right? It was a trap some of you got caught in both the graphing and the writing sections. You would always try and make, you wouldn't necessarily go the easier route because you were always trying to do one specific thing. Do you understand what I'm saying? I said it poorly, but be aware that you can work with either x or y and 1 or negative 1. They both work, okay? Don't get trapped into one specific line of thinking. All right, Joel, please Jordan, please get that entered into your phone so you can put down your phone. Thank you. Because I know all you were doing was putting your calendar on. So we're going to work with this first equation. Now the next step says solve for one of those variables. What does that mean? What do I mean by solve for a variable? Until grade 10, solving meant tell me the number that worked in the equation, yes? But can I do that here? No, because I have two variables. So what I'm actually doing is not solving for a single number, I'm solving for a single variable. Which means, what do I have to do with that equation in order to solve for a variable? What does that mean? Yeah, isolate that variable. So what's the variable that we're going to work with that is highlighted in yellow? We are going to work with x. So our job is to get x by itself. How do we do that? It's a one-step thing. Parveen? We're going to move the 4y, aren't we? Now we're a pre-diploma honors class, so all I'm going to do is this. I'm going to go down here and I'm going to rewrite x equals 4y minus 1. And I'm going to draw that arrow because this is a notes class, right? If I were really had trouble with algebra, if it was still something I was a little bit weak at, of course I would actually do this. Plus 4y plus 4y, and then of course those aren't like terms, so x would equal 4y minus 1. Is everyone cool? Now, just like we have done in the last 2 units, when I gave you something that looked like this, 2, 7, what was that 2? It was an x, and what was that 7? A y, which meant we could put them anywhere in the equation, correct? Right? Well, what does this say? This says that x is 4y minus 1. Agreed? Everyone agree? Okay. Well, what is that? That's an x. What is x? 4y minus 1. So this becomes 3, not x anymore, 4y minus 1 plus 5y equals 31. Now you guys should already see how to finish this. Because what have we done? We have gotten rid of one of those variables, which means now we can find a single number, can't we? Doing grade 9 algebra. So what do I do? What do I do with that? Distribute first. So what do I get? 12y minus 3 plus 5y equals 31. Now what? Collect like terms. 12y and 5y is 17y minus 3 equals 31. Add 3 to both sides. 17y equals 34. And what does y equal? What does y equal? 2. Now, I now have y equals 2, which means in my answer, because my answers are always in coordinate form, what do I have? What will I have? The y. Everybody with me? Do I have an x yet? No. But what do I have? I have x equals 4y minus 1. What's y? 2. So that means that x equals 4 times 2 minus 1, which is? Does everyone see how it works? Now, let's check. Do I need to check both of these? Yes or no? No, of course not, because we just checked this one, which is the same as this one. That's why they're both highlighted. So I don't need to check that one, do I? But do I need to check this one? Do I write it out? No, because I'm an honor student. What's 3 times 7? 21. What's 5 times 2? 10. What's 21 plus 10? 31. So am I right? Is there any excuse to not get these questions correct? No, because that's how easy it is to check. Everybody cool? All right. Now, I didn't want to, what's the word I'm looking for? I didn't want to prejudice you against this method, but this is my least favorite method. Okay? Well, that's not really true. Graphing's my least favorite method because graphing doesn't work in real life. Of the other two, the algebraic methods, this is my least favorite. But sometimes it's very useful. I tend to not use this one. But some students really like it. You still need to know both. Because I want you to have this available when it's the right decision. Do you understand what I'm saying? Because sometimes it is the right decision. Even though I don't prefer to use it, sometimes it's the right decision. Kind of like how I don't really like Pepsi, but when I go to Boston Pizza and I ordered a Coke and they say, is Pepsi all right? You can't really say no because it's your only cola option. Understand? So sometimes Pepsi is the right decision. Some of you crazy kids, because you're younger and hip, you prefer Pepsi to Coca-Cola, which I don't understand. But some of you do. How many of you prefer Pepsi to Coca-Cola? Be honest. I won't yell at you. Of course there's a difference. You can't tell the difference? You guys are crazy. One tastes good and one tastes like battery acid. Shocking. Maybe at the end of the year we'll do the Pepsi challenge. Some of your parents are old enough to remember what the Pepsi challenge is. All right, let's go on to the next one. Which equation are we going to use? The top one. Can I use it in that form? Yes or no? No, I cannot use it in that form, so I have to rewrite it. I always like to rewrite it down here where I'm working. Y equals, now here's a mistake a lot of kids make. You guys pull this 2 over here and you rewrite this, don't write what I'm about to write. You rewrite this as negative 2x plus 3 because you want the x first. Then you have this negative out in front, which for some reason causes even those of you that are A students to make computational errors later on. Understand? So I prefer to write this as 3 minus 2x, which for some reason creates less computational errors. I don't know why that is. But in my 17 years of marking math papers, I have found that if you don't open with a negative, you guys do better when it comes time to distribute and stuff. I don't know why that is, but it's just the way it's been going for 17 years.
Sorry.
No problem.
We're monitoring our own exams.
Yes?
So you're monitoring your own Math 9 exams?
Yes.
You have one block, yeah?
Yeah.
Okay, cool. So then Thursday in the afternoon of
Yeah.
the 23rd,
Yeah.
can I use your room for an exam?
Yes.
Can you monitor it for me?
Yes.
Because I'm monitoring one next door.
Yes.
Thank you. Have fun.
No problem.
23rd, same day as yours.
But in the afternoon. He's kind of my boss, so I had to just say it. I wanted to whisper all that because I don't want it recorded. I don't want the video to happen. So, of course, I took care of that business perfectly well. So, back to where we were. Again, I don't care, okay, if you like to have your X's first, put your X's first. I'm just letting you know that sometimes that causes grief. Now, of course, does anything change? No, of course not. I have what y equals. I've dealt with this guy, so I got to deal with this guy. So I rewrite him. 4x plus 3, because I've dealt with y this time. So what goes in here? 3 minus 2x equals 1. And then again, nothing changes. 4x plus 9 minus 6x equals 1. Do my math. Again, ladies and gentlemen, take this slowly. All right? Use the time available to you. Negative 2x plus 9 equals 1. Negative 2x equals negative 8. And x equals what? 4. Positive 4. Now, once I have that, where does that go? In this version of the equation, because I only need a y now, don't I? I've got my answer. It is definitely 4 comma something. So I am only missing my y. So I go to here, and I go 3 minus 2 times 4, which is, of course, 3 minus 8, which is, of course, negative 5. And then I check. Do I need to check with the blue one? No, because that's the one I just checked on. Check here. What's 4 times 4? 16. What's 3 times negative 5? Negative 15. 16 plus negative 15 is 1, so we're right. Everybody good? That's how easy this is. Now, we're going to do one more, and then we're going to take a moment to discuss how this actually works for us in real life. Rough day at the office, Noah?
Yeah. My alarm clock didn't work. I slept in for 2 hours. But it's nice.
All right, now we're in a bit of trouble. Why are we in trouble?
Because there's no coefficient.
There's no coefficient of 1. So now, you've got to make a mathematical decision. Since there's no coefficient of 1, we are going to throw out the first step, which is choose a coefficient of 1. Right? We have to throw that out. What's the next step?
Choose if you want to solve it with an x or a y.
Choose if you want to solve it with an x or a y. Lovely. And to solve it with an x or a y, we're going to have to do algebra, yes? Which of these two options allows me for better algebra?
First one.
The first one? The second one. Why the second one, Alon? Because 20 divides by 4. Does everybody understand? Some of you on your test will do this one and get a bunch of fractions and try to work it out, filling up your whole page with work. And then when I give you back the test and we go over it and I say, couldn't you have just divided 20 by 4? All those people will do this because they hate fractions, as do all of you. Avoid fractions like the plague because they cause you great grief. Understand? So we are not going to use the first one we see this time. We are going to use this one. But we are still going to rewrite it. But it's going to take a couple of steps, isn't it? Which one do we have to use? Again, you have to make a decision. Do you want 4 divided by 20 or 20 divided by 4? 20 divided by 4, aren't you? Except, look what's going to happen. So, I want 20 divided by 4, which means I got to go 4x, right, equals negative 3 plus 20y, correct? Then what would I do? I'm going to divide by 4, yes, because I need x alone. So I'm going to get x equals, oops, not 4y, 5y. I'm stuck with a fraction, aren't I? Right? That's no good. Is there any way I can avoid this fraction? I'm not saying if there is a way to avoid the fraction or not. I'm saying look at that. Is there a way to approach this question avoiding fractions? You can't do it, can you? Because if you move the 20, if you move the 4, if you move the 4, then you're dividing by 20, you got a fraction. Right? You actually got double fractions because you got 3 and 20, don't you? What about up top? If I move the 4, I got 4/5 and 1/2. Ew, there's no way around it. Does everybody understand? Here is where using substitution breaks down. Remember how I said it's not my favorite? This is why. Because sometimes you're stuck. And we got no choice here. So, since we're stuck, and I am forcing you to use substitution, let's work it through. So we've got our x, so now I go up to here, and let's solve it. And watch what happens. I end up with 4x, which is negative 3/4, plus 5y, plus 5y equals 2. Now you can already see why it's going to work out okay for me, can't you? What's going to happen with those first two 4s? They're going to cancel out. So it ends up being okay, yeah? But it's not always going to end up being okay. And the thing I teach you tomorrow will fix this problem. Okay? So we'll get rid of this now. Negative 3 plus 20y plus 5y equals 2. 25y equals 5. What does y equal? Pardon? No. 1/5. Because it's 25 divided by 25. Okay? Algebra is going to let you down on this because you are going to do what you just did. Your brain wants this answer to not be a fraction, doesn't it? Because you all are scared of fractions. Right? Kind of like the way 16th century people were scared of witches. You're scared, you have an innate fear of fractions. So you want fractions to not be part of your answer. That doesn't mean you get that. Everybody cool? So our y is 1/5. So we know it's 1/5. Yuck. But we're stuck with it, aren't we? So where are we going to go? We need an x. Right here I have what x equals, yeah? So I'm going to take this y equals 1/5 and I'm going to bring it right to there, which is going to give me equals negative 3/4 plus 5 times 1/5. Oh, it's going to work out for us anyway, isn't it? Because what happens to those 5s? Cancel out, and I get negative 3/4 plus 1. And that's easy, yeah? What's the answer? No. 1/4. Because remember, this, of course, is the same as 1 minus 3/4. Now I go up to here, and I write it in. Do I have to check? Of course I need to check. Again, you're scared of fractions, but look at what we did by making a smart decision at the beginning. 1/4, 1/5. 4, 5. What happens to the 4s? They cancel. 1. What happens to the 5s? They cancel. 1. 1 plus 1 is 2. And we know we're right. Is everybody cool? Pardon? Yeah, it does. It does get a little sneaky. But like I say, tomorrow I'm going to show you something that fixes this problem. Takes care of it for you, so their fractions are out the window. All right? Unless, of course, a fraction is the final answer, which leads me perfectly in a segue, because I'm that slick, to this point. How many of you, when you were doing your graphing questions, found that on occasion the lines didn't cross at an exact coordinate? So sometimes you're stuck with fractions, right? Which is why graphing is the least useful of the ways to solve a system. Now, how does graphing help you if it ends up at a fraction? Well, if you take the 1 second it takes to graph something, do you then have a vague idea of what the answer is going to be? Yeah. So then when you do all your work, your algebraic work to find the exact answer, if it's nowhere near where you graphed it and you knew you graphed it correctly, what does that tell you about your algebra? That it's wrong and you should go back and check it over. Understand? I'm telling you right now, even I, when I am faced with a complicated systems question, because remember, a system can be 2 or more equations, can't it? When I'm faced with a complicated systems question, I sketch its graph first, because I can sketch a graph pretty quickly. And I get a vague idea of what the answer is going to be before I bother doing a page of algebra. Understand? Okay. Does everybody feel fairly comfortable with substitution? I have, of course, applied one textbook page to you. Not very much, because the textbook, this is boring. Right? I don't dig substitution. So how do I make it more fun for you? I get you a puzzle sheet. So you get a joke about it as well as learning how to do it. Now, is your puzzle sheet in those notes? I was hoping it would be. Damn! All right, I will print it off while you start on the textbook work.